positive charge and negative charge within an atom. Therefore, Z is also the number of electrons. So when you look at a symbol like this number tells you how many protons and neutrons total in that particular element here. This number tells you how many protons and how many electrons are in there. So using this particular symbol, you will be able to determine the total number of protons, neutrons, and electrons. Remember, that's our first learning objective. We want you to be able to identify the total number of these particles within an atom there. So this is something that I want you to memorize. You need to know what A stands for, what is Z stand for. A is the atomic mass, okay, and that's the number of protons plus a neutron. Z is the number of proton and number of electrons. And they have equal numbers simply because we have equal number of charges here. Okay, so A minus Z will give you the number of neutrons. So this is kind of like a definition thing. You have to know how we define A and Z. And when we use those numbers to represent different number of particles within an atom. Okay, so the number of protons equals the number of electrons, we say that, and then that tells you the atom, any atom, atoms of any element is charge neutral to begin with. Before they start to interact with other elements, there are equal number of protons and neutrons within any atom there. So there is no net charge. I should have the word net in there. The atom is said to be neutral. There is no net charge. There are positive charges in there, and there are negative charges in there, but you have equal number of negative charge and positive charge. So the atom itself is charge neutral. There is no net charge. Okay, and now the question is, how is carbon, if all of the atoms are made up of protons and neutrons and electrons, why do we have different atoms there? How is carbon, an atom of carbon, different from an atom of silver? Well, the difference lies in the total number of protons, neutrons, and electrons in here. For carbon, we have 6 protons. So how do you know that? Well, we have a document that we call the periodic table. And if you look at the periodic table, carbon is number 6 in that table there. Number 6 means you have 6 protons in there. And silver has 47 protons. Okay? So in this case, if you have 6 protons in carbon, you would have 6 electrons in there as well, because it's charge neutral. So you would have somewhere around 47, we'll have 47 electrons in silver. So the difference between these two types of atoms really is the total number of protons, electrons, and neutrons are different from one another. And imagine you are a magician. Chemists is kind of like magicians. Okay? You have at your disposal a jar of protons, a jar of electrons, a jar of neutrons there. Now if you take 6 protons out of the first jar, and you take 6 electrons out of the second jar, and then you take 6 neutrons from the third jar, you put them into another bottle, you shake it, you get carbon. Okay, 47 protons, 47 electrons, and a certain number of neutrons there. Now, the number of neutrons can actually vary within the same element there. For the atoms of within the same element, you may have different number of neutrons there. Okay, so if you put all those particles together and you shake them, you get silver. So that's how the elements are different from one another. So when we try to determine using the atomic symbol, using the way that we represent them, when we're talking about how do we represent the atoms there, X and A and Z, using that representation there, based on the information given, we should be able to determine the number of protons and electrons and neutrons in there. So carbon, X, now becomes C, 6 and 12 there. So how many protons do we have here? Z is the proton, number of protons. So we have 6 protons. Now if you know the number of protons, you know the number of electrons, because we have equal number of charges there. So we have 6 electrons. And 12 minus 6, we have 6 neutrons. Okay, so that's our carbon atom in a nutshell. And we have 3 different particles, and then we can also determine the total number of each particle there. Now keep in mind, carbon, element of carbon, they actually have different types of carbon atoms, just like within the family of brothers and sisters. So all of those siblings there, they would have the same number of protons. they would have the same number of electrons. The number of neutrons may be different. So you hear the term carbon-12, meaning that carbon has a total of 6 neutrons. Carbon-13, 6 proton, 7 neutron. Carbon-14, 6 proton, 8 neutron. That's the idea of isotope. We'll get to the isotope in just a little bit. So for silver then, if you look at the silver there, the information given in the periodic table, the atomic representation there is that silver Ag, okay, and 10947. How many protons do we have? 109. Who said 47? It is 47. Okay. So how many electrons do we have?
47.
47. And the number of neutrons? 109 minus 47. So in this case, you do have 62 neutrons in there. And the silver does have other siblings, the elements within the family of silver, and there are different types of silver atoms there. So the number of neutrons can actually vary from one to another. Okay. So this is how we determine the number of subatomic particles in any given element there. If we give you a periodic table, and you would know the atomic mass number, you would know the you would know the mass number, you would know the atomic number there. So you are given Z and A, and based on the relationship there, you can determine the total number of protons and neutrons. Right? Now, in your homework assignment, and you will see this type of exercise, and we give you a particular element, atoms of a particular element there, and we give you the information there, 47, 109, things like that. And you need to be able to figure out the number of protons and electrons and neutrons there. Okay. You will see this type of question in your homework, and I guarantee you, you will see this type of question on the upcoming exam next Thursday. Okay. So take another look. Take a look at another example there, uranium. Okay. 92, 238. We have protons, electrons, and neutrons. 238 minus 92 to 146. Okay, so any elements that we give you there, and if you can find them, the information, once you locate them in the periodic table, then you will be able to determine the number of protons, neutrons, and electrons. Well, so why do we need to know that? Well, because the number of proton, number of electron actually determines the behavior of the atoms there. Remember at the first day of class there, we're talking about chemistry is the science that trying to study the behavior of matter and trying to understand the behavior of matter by studying the behavior of atoms and molecules there. Well, in order to understand behavior of atoms and molecules there, you have to know the basic components of those atoms and or molecules there. You have to know how many protons are in there, how many electrons are in there. And more than often, the number of electrons, number of protons will determine the chemical property of that particular element there. So this is something that we need you to be able to do, and there are plenty of exercise in the homework assignment in chapter 2 there. So pay attention to these things. Okay, so talking about the number of protons, number of electrons, then we come up with the term of what we call isotope. Now, isotopes, by definition, are the atoms with the same atomic number but different mass. Or in a sense, if the mass of the atom is determined by the proton number of neutrons there, if they have the same atomic number, well, that means they have different number of neutrons. Now, the term isotope refers to the atoms within the same family. Okay. Now, in order for something to